All right, everybody, we're looking at the first section of our topic 6 notes that is talking about polygons. All right, polygons. So, on the first page of those notes, we have definition of what a polygon is. Okay, this page right here is just an example of a few of those of what polygons could be, what they look like. Um, it is a two-dimensional closed shape that's made out of straight lines. Okay, so that's important right there. It is a fully enclosed shape that doesn't have any curved lines. So there's no circles and no half circles, no curved lines. It's all straight lines that make a shape. Now, polygon can be split into two different categories. It can be either convex or concave. Here's your definition for a convex polygon. Okay, it says that each interior angle is less than 180 degrees and none of the angles point inward. And here's what I mean by that. Okay, on both of these convex polygons, all of the angles, as you look up, like right in there, it points away from the inside of the shape. It points outside of the shape, and all of those are true corners of your polygon. Okay, a concave polygon is the one that's in opposition to that. Concave polygon does have at least one angle that points inward. So when you look like at this right here, this corner of the polygon kind of cuts into the shape. Same with this one right here. It cuts into the shape. It points towards the middle of the shape rather than towards the outside. All right, so that's your definition for convex and concave. The other way that polygons can be categorized is by regular or irregular. So if it is a regular polygon, and this is going to be important as we talk about more stuff in this unit, a regular polygon has all the sides congruent to each other and all of the angles congruent to each other. So when you look at this first shape right here, you can see one hash mark on each side. You can see one arc inside of each angle. That means this is a regular shape. Same with this one. All of the angle markings are the same. All of the side markings are the same. So both of those would be regular polygons. This last one, however, you can see that this side is a lot longer. You can see that these two angles are different than like this one or this one down here. Okay, that would be an irregular polygon. Now, the idea of a regular polygon, the important thing you need to remember is all the sides and all the angles are congruent. That's what's going to come up later in our notes a little bit here in just a second, and it's going to come up a whole bunch in the next couple of sections. All right, so that's what a regular polygon is. Okay, what we're going to talk about now is the interior angles of polygons. All right. What we're going to do to fill out this chart, we have four things that are missing from each row in this chart. First off is the name of the polygon. Okay, we already know how many sides it's going to have. Now we need to figure out what the name is. The picture of it is already drawn, an example of that kind of polygon. The next thing is the number of triangles, and we're going to talk about that probably more with the 4 and 5-sided one. The third thing is going to be that number of triangles times 180. That'll give us the sum of the interior angles. And that sum divided by the number of angles is where we're going to get this last column of the chart. All right, so all of this stuff hopefully is going to make more sense as we go through and as we get to it and explain. All right, so our first thing right here is the number of sides. All right, the number of sides is 3, so obviously we already know that's going to be called a triangle. Okay, we've dealt with triangles from the very beginning in this class. Okay, for the number of triangles, go ahead and just put 1. Okay, we're going to talk about what the number of triangles means here in a second when we get down to these two, but just leave it as 1 right here. Step number 3 is the number of triangles times 180. And this is something actually we already knew about triangles too. When you add up all of the angles inside of a triangle, the sum of those interior angles is always 180 degrees. We've talked about that time and time again. Every single triangle ever created always adds up to 180 degrees. Now, this last column is a little bit unusual, okay? It's asking for what is the measure of each interior angle of the regular version of this polygon. Okay, the regular version of a triangle, think about this. We got to think back to our definition of regular. It means that all the sides are congruent and all the angles are congruent. So we know that no matter what the angle sizes are, they're always going to add up to be 180. That's in every single triangle, it always adds up to 180. But if it's a regular triangle, that means all of those angles are the same. All three of the angles are going to be the same. So we can just take that 180 and divide it by 3. And that's where this number comes from. This 60 that goes in this blank right here, it comes from dividing that number of degrees evenly in between all three of those angles. Okay, that pattern is going to continue all the way down as we move along. All right, I want to go now to the second row right here, the four-sided polygon. All right, if it's got four sides, you may remember this word from back in probably 6th or 7th grade, a quadrilateral. Okay, there's a whole bunch of different types of quadrilaterals, and we're going to talk about those in one of the later sections. Okay, there's a bunch of different kinds of quadrilaterals. You could have squares and rectangles and trapezoids and parallelograms and a whole bunch of stuff. But if it has four sides, it can be called a quadrilateral. All right, we have four angles, four sides in this thing. Now, here's something that happens, okay? When we talk about the number of triangles, what we mean is the number of triangles that can be made when you connect the corners of the shape together, okay? So when we look at point number 1, it is already connected to point number 2, and it's already connected to point number 4. That's just the edges of the shape. But when we connect point number 1 to point number 3, like that, well, you can see that splits our quadrilateral into 2 triangles. Okay? Look at what happens if we try to connect the other corners. Okay, if we connect 2, point 2 is already connected to 1 and 3 by the edges of the shape, but when we connect 2 up to 4, again, that splits it into 2 separate triangles. All right? So when we're talking about splitting it into a number of triangles, that's what this number is. Okay, and that number for a quadrilateral is going to be 2. Okay, so think about this. Every single triangle always has 180 degrees, right? And so that means the top triangle here and the bottom triangle here, both of those triangles' corners would always add up to 180. So that means if we added all of these degrees plus all of these degrees, that would give us all of the number of degrees for the whole thing. So we take that 180 and multiply it times 2 because there's 2 triangles. That's what this number is over here on our step number 3, number of triangles times 180. It's 180 times 2. That's where this number 360 is going to come from. Okay, so that means on any four-sided shape, if you add up your angles, it's going to equal 360. All right. So again, we think about what is a regular quadrilateral. All right. According to our definition of regular, it means all of the sides are congruent and all the angles are congruent. So if we know that any quadrilateral is going to add up to 360. And if we evenly split that into 4 angles, well, that's just 360 divided by 4. And that's going to be 90. Now think about this for a second, okay? A regular quadrilateral has 4 sides that are all the same. 4 90-degree angles. A regular quadrilateral is just a square. All right, I think that's pretty cool how that works out. Okay, our last one, our 5-sided, if our number of sides on the polygon is 5, that is what is known as a pentagon. There's a fun building over close to Washington, D.C., home of a bunch of military stuff called the Pentagon because it's shaped like a gigantic regular pentagon. It's got 5 sides that are all about the same length. All right? So when we talk about splitting it into a number of triangles, again, all we're doing is connecting the corners together. So when we look at point number 1, it's already connected to number 5. It's already connected to number 2. But if we put a connector right there and another one right here, you can see that this is now split into 1, 2, 3 triangles. All right, you can do the same thing no matter what corners you're connecting together. If you do it from number 2 right there, and right there. Again, we've got 1, 2, 3 triangles. Try it again over here. We connect that one, and we connect that one. Oh, wait, we already did that one. We already did that. Hang on. We connect that one, and we connect that one. Once again, 1, 2, 3 triangles. Every single time, a pentagon can be split into 3 triangles. So that means if we take this number 3, and we know that there's 180 degrees in the angles of all of those triangles, we take those 3 triangles and multiply it times 180. That gives us our total number of degrees in a pentagon, which is 540. We also know that in a regular version, okay, that's our key word right here is regular. If it is a regular version of a pentagon, then that means it's going to have the same number, it's going to have exactly the same angles all the way around. Okay, so we take that 540 and divide by 5, and that's where this number comes from, 108 degrees in each one. All right, that is the end of the notes for our first section about polygons. We'll get back at it again another day to continue the rest of them. Y'all have a good one.